Alrighty, we're back in business. Got the computer again. Kind of limping along, but today we'll do the lecture on synthetic division. So let me see. Text box. Here we go. Synthetic division. How do you spell that? SYNTHETICDIVISION. Synthetic division. Insert. Okay, that's not very big, but anyway, you can read that from where you are. So, synthetic division is just a little shortcut for the polynomial division that we learned the other day. So, it helps you do polynomial divisions very quickly, but they have to be in a particular form, otherwise they don't work. And the form they have to be in is, oh, that was a marker, fine chisel, is the binomial. They have to be dividing by a binomial, and the binomial has to have a coefficient of 1. Otherwise, it's not going to work. So let's take one that I can do with polynomial division. So I'm going to take 3x cubed minus 4x squared plus 5x minus 7, and I'm going to divide that by x plus 2. So again, this is going to work because the coefficient on the x here is 1, and this is a binomial. Otherwise, I have to go back to polynomial division. Alright, so here's what we do. We take that 2 right there and we do the opposite sign. So that's positive, that's x plus 2. So the opposite sign plus 2 minus 2. So we change that 2 to a negative 2 and we put it in a funny little box here. Then we take the coefficients for all of the variables in the polynomial. We take the coefficient for the x cubed, that's a 3, the x squared, that's negative 4, the x, that's 5, and we take the constant, negative 7, and we write them down horizontally. We make a horizontal line, but give ourselves a little working space. The 3 we take and just write down right below the line. Then we take that 3 and we multiply it by the negative 2 that's over here in the box. Negative 2 times 3, that's negative 6. I put it right under the negative 4, the coefficient for the x squared. Now I add negative 4 plus negative 6, that's negative 10. Now I take that negative 2 again and I multiply it by the negative 10. Negative 2 times negative 10 is positive 20. Now I add 5 plus 20 is 25. And now I do it again. 25 times the negative 2, that's negative 50. Put it right below the negative 7 there. And negative 7 plus negative 50 is negative 57. Alright, the number on the far right is the remainder. The next number is the constant term. The next number is the linear term. That'll be the one that'll be with the x. The next number will be the x squared up until we run out of numbers to the left. So this division becomes 3x squared minus 10x plus 25 with a remainder of negative 57. So that's synthetic division, and let's do this to apply to some other problems. So we'll see how this can help us if we're factoring. So let me go down the page a little bit here. Let's see. Okay, that's the whole page. Gotta get used to a new thing. It's kind of like writing on lined paper, isn't it? Alright, so the next thing we're going to do is we're going to try to factor x cubed minus 7x minus 6. we're going to try to factor that, and I'm going to say that I already know one of the factors. I'm going to say that one of the factors is 3. Now I want to find the other linear factors, whatever that's going to be. So if one factor is 3, x cubed minus 7x minus 6 is x minus 3 times something. And let me see if I can figure out that something. How am I going to figure out that something? Well, I'm going to take x cubed minus 7x minus 6, and I'm going to divide it by x minus 3. I'll use my synthetic division, since I know how to do that now. Alright, I changed that negative 3 into positive 3, and I put it in the little box. Then I write my coefficients. The coefficient for the x cubed, oh, that's a 1. Coefficient for the x squared, oh, there isn't an x squared here, so I write a 0. Coefficient for the x to the first power, oh, that's negative 7. Then I'm down to the negative 6. Now I do my little synthetic division, bring the 1 straight down. 3 times 1 is 4. 0 plus 4 is 4. Now I take the 3 times the 4, that's 12. 12 minus 7 is 5. And I have done something wrong. And I'm dividing it by 3, 0. Oh, jeez. 3 times 1 is 3, not 4. Here we go, sorry. 0 plus 3 is 3. 3 times 3 is 9. There we go. 9 plus negative 7, that's 2. 3 times 2 is 6. And negative 6 plus 6, that's a remainder of 0. Whew, there we go. Survived that one. Alright, so x cubed minus 7x minus 6 divided by x minus 3 is, this is the remainder, 0, constant, the x, the linear term, x squared, quadratic term. So that's 1x squared plus 3x plus 2. Oh. So I already had one factor, x minus 3. And I can factor x squared plus 3x plus 2. That's my basic trinomial factoring. That's x plus 2 times x plus 1. So the factoring for x cubed minus 7x minus 6 is x minus 3 times x plus 2 times x plus 1. Pretty cool. All right. Now let's see another great thing that we can do with synthetic division. It's just a great thing that we can do with division in general. It's kind of an interesting fact. I don't know if you'll actually ever want to use it, but there's something called the remainder theorem. Remainder, that's an A. Why don't I be smart and put that in a text box? Insert a text box right here. Go get my little text thing. Remainder, M-A-I-N-D-E-R. Theorem, T-H-E-O-R-E-M. Haha, isn't that clever? Alright, the remainder theorem says that if I have a polynomial, boy, this probably won't write out very well, but I think I have to do this by hand. If I have a polynomial, grab this, p of x, is this pen just a, do we need a little better marker?